video, we're going to be having a look at hydrocarbons. Now, you need to be able to define the term hydrocarbons, and it's a very simple definition. A hydrocarbon is any molecule that contains only hydrogen and carbon atoms. That's it. All right. Now, sometimes we talk about organics. Organics can have other ones, but if it is a hydrocarbon, it must only have hydrogen and carbon. What we're going to have a look at doing is looking at two different homologous groups. So that's where they all have a similar chemical property, a similar chemical group. And we're going to have a look at sort of how they appear in some of their properties. So let's move on to the first groups. The first big group is alkanes. And you can't quite see the title, so that's an A there, alkanes. All right. And there is another one, and that's one that looks like this. So it's only got one carbon. Now, this is called methane. And we have a way of naming these, and it's all dependent on the number of carbons that they've got. So methane has got one carbon, ethane 2, propane has got 3, butane has 4, and pentane has got 5. And then we go through the shapes. So a pentagon, pentane, then hexagon. The next one, 6 carbons, would be hexane. These have got a general formula, and you do need to know that general formula. So the general formula for all alkanes is CnH2n plus 2. Okay, what that means is that if we take ethane, for example, it has got 2 carbons. So that's N, C2. Therefore, I will multiply it by 2 and add 2. So 2 times 2 is 4, plus the 2 gives me 6. 1, 2, 3, 4, 5, 6. And this will work for all alkanes. So that's how you determine whether it's an alkane or not. You also need to be aware of the endings. So you'll be able to identify from the names. If it's an alkane, it has ANE at the end. If we have a look at another homologous group that's very similar, it's another hydrocarbon, we call them alkenes. Now, alkenes are slightly different in that they've got a double bond. So they have then got the formula, the general formula of CnH2n. So for every carbon, it's got twice as many hydrogens. 2 carbons, 4 hydrogens, 3 carbons, 6 hydrogens. Okay, but we use a similar naming principles. So if it's got 2, it's F. If it's got 3, it's prop. If it's got 4, it's but. If it's got 5, it's pent. You don't have to worry about this one until A level. That just shows you where the double bond is. And you need to have a look at covalent bonds to sort of get a better idea of what this means. But each of these is a shared pair of electrons, basically. Now, the thing with alkenes is because they've got a double bond, they've got a double E. So that's the way I always remember it. In terms of the way we name it, like ethane, there you go, an A and an E, single bond. So it's got one E there. Ethene has got a double bond, it's got 2 E's. That's the way I've always remembered it. And the test to see whether you've got an alkane or an alkene, because they have relatively similar properties in terms of boiling points, melting points for their size. The way to determine whether you've got an alkane or an alkene is to add bromine water. Because what bromine water will do is it will break one of those bonds and you'll form 2 single bonds, and the bromine will join onto them. So what you'll see is just with a little drop of bromine water, the colour of the bromine water will go from orange to colourless. And that's how you test for an alkene. So what does this actually look like? Well, as I go across and I get bigger molecules, so these molecules are getting bigger as I go from ethane, propane, butane, pentane, they're getting bigger. And as they get bigger, you get some change in properties. Now, these are some of the sort of more middle ones. If we go over here and look at stuff like methane and ethane, it will be a colourless gas. If we go over here to where we've got sort of hundreds of carbons in that chain, so we don't even worry about the name of it, we've got things like bitumen. And you'll learn more about that in terms of fractions when we look at how fractional distillation works, because these all mix together to form crude oil, which is what we get from the ground. Crude oil is pretty pointless, really. It doesn't have much of a function until we divide it into those individual groups. And those individual groups have different properties. One of those properties is the coloration. So as they get bigger, they get a lot darker, and we can see that here, and that's partly due to some of the impurities that sort of latch onto the carbons. The other key property here is that they get much thicker down this end, so we call that viscous. They're less flammable down this end, so they're more flammable over here, higher boiling points, melting points, and so we end up with certain properties that we can use for different things. If we set fire to ethane down here, for example, it will set fire very quickly because it's a gas. If I try and set fire to bitumen all the way out here, even with a flamethrower, it will not set fire, or it will be very difficult to set fire to. So this is why diesel, which is further up here than petrol over here, doesn't use spark plugs to actually ignite the fuel.